Hello everyone, welcome back to the channel. I am Nikhil Kumar. Most Kubernetes beginners expose their application using a plain HTTP, and that's like locking your house but leaving the door wide open. In production, you must use HTTPS for security, trust and compliance. In this video, I will show you a complete real-world demo deploying a web application, exposing it using NGINX Ingress and securing it with TLS. This video is beginner friendly but production focused. We will start with a simple NGINX application and end with a fully secure HTTPS setup, which is something you can directly use in your real world Kubernetes environment. So let's start by deploying a simple NGINX application. This could be your front-end service, API or a dashboard in production. So this is our Kubernetes cluster. We are going to deploy a NGINX application using a resource called deployment. For that I am going to use a kubectl command. So kubectl create deployment and the deployment name, that is my-nginx, and the image name, that is nginx latest. So deployment got deployed. Let's verify it very quickly. Kubectl get deploy. So deployment is in running state, and if we see the pod status, so pod is also running. Now we need to expose this application. So for that we can create a service. So I am going to use a command kubectl expose deployment and the deployment name my-nginx, and we need to specify the port, that is 80, and the target port, which means the port of the container, that is 80, and type is ClusterIP. So ClusterIP. That means we are exposing it internally within the Kubernetes cluster. So the service got created. Let's verify it very quickly. kubectl get svc. My NGINX service is also got created. Right now it's only accessible inside the cluster. To make it reachable externally, we will set up an Ingress controller for that. Ingress acts like a front gate of your Kubernetes cluster. It routes external traffics, handles SSL termination and perform a load balancing. And if you are using a RKE2 cluster like me, so there is a good news. Right now I am also using a RKE2 cluster, that is a Rancher Kubernetes. So it already comes with the NGINX Ingress controller pre-installed. So you can check it with this command, that is kubectl get pod -A and grep for Ingress. And if you see pods like RK2-Ingress -controller, you are ready to go. Otherwise, so you need to install it with the hem by referring the GitHub repository. So this is the GitHub repository for the NGINX Ingress. So you can refer this and install the NGINX Ingress on your Kubernetes cluster. Right now we have a RK2 cluster, so we don't need to worry about that. So we have the controller ready. So let's create an Ingress resource to route our traffic to the NGINX service. So there is a NGINX configuration file. So this is the one. So with this particular manifest file, we are creating a resource called Ingress, and with the name called nginx-ingress, where we are specifying the host, the path and the service details. So here if you notice, we are specifying the service name, that is my-nginx, and we are also specifying the port number, that is 80, and if you notice we are using the host here. So instead of using IP address, so we are going to connect with our application using the host name. So this means whenever someone visits RK2-server, the request is routed internally to our NGINX service, but we are still serving the plain HTTP. So let me create this first. Kubectl create -f nginx-ingress.yml. So Ingress got created. So kubectl get Ingress. So our Ingress got created. So let's try to connect our application very quickly. HTTP RK2-server. So our NGINX application is working fine with this particular host name with the help of our NGINX Ingress. Now to make this secure, we need to add the TLS and enable a HTTPS in the Ingress. In production, TLS certificates usually come from Let's Encrypt or your corporate CA. But for this demo, we will generate a self-signed certificate using an OpenSSL. So this is the command for the same. So it will generate a 1-year valid certificate and the key pair for the hostname, that is RK2-server, the same host name which we have used in our Ingress as well. So our certificate and the key got created, that is tls.crt and the tls.key. Now let's store this securely inside a Kubernetes as a TLS secret. In our last video, we have covered the Kubernetes secrets, but with the one example that is a generic one. But we have another options called TLS over there. So let's quickly see that. kubectl create secret --help. So if you see, in the last time we use generic one, which means we are creating a secret from a local file, directory, or a literals value like a key value pair. And we have a two other option like Docker registry and the TLS. Docker registry is used for storing a Docker registry credential. If we want to pull some images via some code or some manifest file, we can use it over there. Another is that TLS, which we are going to use in this particular demo, which will be used to store the TLS certificates. So let me create a secret very quickly. Right now I already have a TLS cert and the TLS key in my system. So kubectl create secret TLS and my app-tls, that is the name of the secret, and the CRT and the CRT path and the key path, that is tls.key. Right now I just given a name because it resides in the same folder. The secret is already created with this name, so let me create with a different name. So let me update this -nginx. Now the secret got created, so kubectl get secret. So we can see the secret got created with this particular name 5 seconds ago, that is my app TLS nginx. So this secret will be used by the Ingress controller to terminate the HTTPS traffic. And if you like to know how TLS certificates works behind the scenes, how encryption and how key exchanges and trust model operates, drop a comment below. I will make a dedicated video just on that. Now let's connect this secret with our Ingress to enable HTTPS. So for that, let me update the NGINX Ingress.yml file, that is NGINX Ingress.yml, and in this particular manifest file we need to update the TLS secret we just created. So for that, let me go back to this under spec, and we need to specify the TLS information, that is TLS and the host, that is rk2-server, rk2-server. This is the same host name which we gave under the rules as well. And then we need to specify the secret name which we just created, that is secret and name, and the name is my app-tls -nginx and save and exit. Now let's apply this configuration. kubectl apply -f nginx ingress.yml. Ingress got updated, so kubectl get ingress, and if you see, the ingress got updated with the port number 443, that is a HTTPS. Earlier it was having only 80, that is a HTTP based traffic. If you scroll up, if you see, earlier we created an ingress without any TLS secret information, so it just specified the port number 80, but so this time we updated the TLS information, so it updated the port to 443 as well. And finally we need to add an entry in our host file so your local system can resolve the host name, which I already did in this particular system, that is cat/etc host file. You can see this particular information is already updated here. That's why last time we were able to access our application with this particular URL. Now we have updated the ingress with the secret information. Let's try to curl it with the HTTPS and rk2-server. It's working fine, but it's an expected one because we are getting a self-signed certificate warning. So for that we can use curl-k HTTPS rk2-server, and this time it worked fine. Now we are able to access our application using the HTTPS. It's confirming our HTTPS setup works perfectly fine. Now that our demo is working, let's visualize what's happening under the hood. When a user accesses your application, let's say HTTPS rk2-server, the request first lands on the Ingress controller, which holds our TLS certificate information. The controller performs the TLS termination, decrypting the HTTPS request and routing it internally using the HTTP. This way, encryption and decryption happens only once at the Ingress layer only, and it's a best practice in the production setups as well. Then based on the hostname or path, the controller routes the request to the right Kubernetes service, which load balances traffic across multiple pods running your application. So in short, Ingress controller is your secure entry point, service is your internal load balancer, and pods are your actual application containers serving the traffic. And if you like a deep dive on how Ingress routing and TLS actually work internally, comment below. I will plan a full dedicated video just for that. And one point to be noted here, like in production, you would replace the self-signed certificate with one from the Let's Encrypt or your internal CA and automate renewals with the Cert-Manager and serve multiple domains behind a single Ingress controller, and that's how you build a production grade HTTPS setup on Kubernetes, from a simple NGINX application to a fully secured Ingress with a TLS. If you found this helpful, hit like and subscribe for more content like this, and let me know in the comment section if you want me to cover TLS deep dive or the Cert-Manager automation next. Thanks for watching. I will see you in the next one.